Okay, one last definition here that I forgot to have you guys write down. Please add this to your postulated theorems notes, the definition of bisect, okay? And what bisect means to intersect a figure with a point, line, ray, or segment to create two figures with equal measure. Okay, so what that means is if I bisect something, the way we can kind of think of it in terms of segments is I'm going to be cutting something in half at the midpoint, okay? So that we have two equal segments of equal measure. So remember, like the midpoint says that the two endpoints to the midpoint have equal measure. It's similar to that idea of the bisect, okay? So we have something bisecting a segment is one particular example that we need to be familiar with, okay? For instance, if I had AB, okay, segment AB here, I could bisect it with some line, L, okay? And what that means is I cut this segment exactly in half so that we're cutting right at the midpoint, okay? So this would meet at the midpoint M, whatever it happens to be. So when we bisect AB, we now have two equal segments, AM and MB, okay? Another way we can think about it later on is maybe we're going to bisect some angle, and we haven't defined an angle yet, but this is something that may appear, okay? Let's say I have X, Y, W, and Z here. Well, what we're saying here, let's say that YZ, this ray YZ, is bisecting this angle. And what that means is that this angle and this angle are the same. It's cutting the angle in half so that we have two equal measures. So if I bisect an angle, the angle is going to have two equal measures. So this angle here is equal to this angle here. Okay? So what we were saying is in the first example, L bisects the segment AB at M, at the midpoint, so that AM is equal to MB, okay? So L bisected our segment AB so that we had two equal measures, AM is equal to MB. And then in this second example, we said the ray YW bisects the angle, and like I said, we'll learn more about angles later, XYZ, so that we had two equal angles.